Welcome to the second lesson of this course. Now we have understanding of artificial intelligence, its components, how it works, and some of the real-world applications. Let's take a deeper dive into one of the most important areas of AI, which is machine learning. But what exactly is machine learning and how does it fit into the bigger picture of AI? In this lesson, we'll answer these questions and explore how machine learns from data. So, what is machine learning? Machine learning is a subfield of AI that focuses on creating algorithms that allows computer to learn from data and make prediction or decision based on data. Instead of programming every action a machine takes, we train the machine using data and it learns how to perform tasks from its own. In a sense, machine learning enables machines to automatically improve their performance over time through experience, just like humans do. But how does machine learning relate to AI? To put it simply, machine learning is a subset of AI that encompasses a broad range of technologies designed to make machines intelligent. While machine learning is specifically focused on teaching machines how to learn from data, so when we talk about AI doing something smart, whether it's recognizing faces or playing game or driving a car, it's often machine learning at work behind the scenes. So as we discussed in the earlier lessons about the types of machine learning, there are three primary types of machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. Each of these techniques uses data in a different ways to teach the machine how to make decisions or predictions. We started talking about supervised learning, which is a type of machine learning that learns from labeled data. When you give the machine an input data and the correct output, which is the label, and the model learns to map the inputs and outputs. It's like teaching a kid to identify animals by showing them a picture with labels. This is a cat or this is a dog. An example of supervised learning, which is the image classification model. Imagine we want to build an AI model that can identify animals and photos. We feed the system thousands and millions of images. Each is labeled as a cat or a dog or a bird. The machine uses these labeled examples to learn the patterns and the characteristics of each animal. Over time, it can recognize new images of animals, even those it hasn't never seen before. Let's move to the unsupervised learning. The unsupervised learning learns that the data is unlabeled. The machine tasks is to discover the patterns or structures in the data without any explicit guidance on how to look for it. It essentially has to figure things out on its own. When we talk an example of unsupervised learning, we talk about the customer segmentation. Think as a company might have a large set of data about customer behaviors, but without specific labels. The machine uses unsupervised learning techniques to cluster the customers into different groups based on their similar behaviors, like frequent buyers or seasonal shoppers or those who prefer discounts. The third type that we're going to discuss about, which is the reinforcement learning. Reinforcement learning is a bit different from the first two. In reinforcement learning, the machine learns by interacting with an environment and receiving rewards or penalties based on its actions. It's like training a dog. The dog learns behavior based on whether it's giving treat or treat, or scolded. An example of um, reinforcement learning, which is AlphaGo, which is game playing model. One famous example, which is AlphaGo, which is an AI program that played and defeated the world champion Go players. AlphaGo uses reinforcement learning to explore different strategies, receive feedback based on whether it wins or it loses, and continuously improves its decision making. Next, we have unsupervised learning. In unsupervised learning, the data is unlabeled. The machine task is to discover patterns or structure on the data without any explicit guidance on what to look for. It essentially has to figure things out from its own. An example of unsupervised learning, the customer segmentation model. When a company might have a large set of data about customer behavior but without specific labels, the machine uses unsupervised learning techniques to cluster the customer into different groups based on similar behaviors, like frequent buyers or seasonal shoppers or those who prefer discounts. Reinforcement learning. This is a bit different from the first two. In reinforcement learning, the machine learns by interacting with an environment and receiving rewards or penalties based on its action. It's like training a dog. The dog learns behavior based on whether it's given a treat or scolded. An example of reinforcement learning when playing a game called AlphaGo. One of famous examples is AlphaGo, which is an AI program that played and defeated the world champion, which uses reinforcement learning to explore different strategies, receives feedback based on whether it wins or it loses, and it continuously improves its decision making. Now that we have covered the main types of machine learning, let's talk about some of the most common algorithms used in machine learning. These algorithms are tools that machine uses to learn from data. To simplify the definition of algorithm, we can say that they are pieces of code that helps people to explore, analyze, and find meaning in complex data set. Each algorithm is a set of step-by-step instructions that machine can follow to achieve a certain goal. There are many different types of machine learning algorithms like linear regression, like knife bias or nearest neighborhood or support vectors machine, posting and add post algorithms. In this example, we will discuss about the decision trees. The decision trees are one of the most innovative algorithms. It works like a flowchart. At each branch, a decision is made based on a specific feature, like is the animal small, is big, or does it have a fur? Based on the answers, the tree makes a final classification. Let's talk about one of the most popular algorithms, which is called linear regression. Linear regression is used for predicting continuous value. For example, predicting the price of a house based on its size or location or number of bedrooms. The algorithms find the line of best fit to make prediction based on historical data. The next algorithm that we're going to talk about, which is the k nearest neighbors, is a simple yet an effective algorithm for classification. It works by identifying the closest data points to the one it's trying to classify. and then using the majority vote of these neighbors to make a decision. Now let's talk about something else, a popular evaluation matrix. When training a machine learning model, you need to evaluate how well it's performing. These are an evaluation metrics. Also, there are several evaluation metrics that we use to measure its effectiveness. Let's take a look at the most common ones. The first one is accuracy. Accuracy measures the overall percentage of correct predictions. It's calculated by dividing the numbers of correct predictions by the total number of predictions. However, accuracy might not be the best metric if your data is imbalanced, where one class appears much more frequently than others. The next one, which is precision and recall. Precision tell us how many of the predicted positive instances were actually correct, while recall tell us how many of the actual positive instances were identified. Precision and recall are especially useful when dealing with imbalanced datasets like fraud detection, where false positive or false negatives can have a serious consequences. F1 score. F1 score is a harmonic mean of precision and recall, and it's good metric when you need to balance both. It's especially helpful when the class distribution is uneven. So let's quickly recap on what we have covered this session. Machine learning is a powerful technique that allows machine to learn from data and make predictions. We have explored supervised learning, unsupervised learning, reinforcement learning, and we've discussed the common algorithms like decision trees, linear regression, and k-nearest neighborhoods. We've also reviewed the key evaluation metrics like accuracy, precision, and recall, and F1 score.